Sound travels faster in salt water than it travels in air. Let's assume that the speed of sound in salt water is 1,535 meters per second. Some whales can locate objects near themselves by sending out a brief pulse of sound and listening for the echo reflecting off some object. Let's say the delay between when the whale makes a noise and when they hear the echo is 420 milliseconds. How far away must the whale be from the object if the object and the whale are both stationary? The whale is going to send out his brief pulse. It'll strike the boat, and when it reflects back, that could then be sensed by the whale. We need to figure that the sound is going to spend half of its time traveling toward the object, and then the other half of its time traveling back. So one way we could approach this is to figure that it's going to be 210 milliseconds of travel to the boat and then 210 milliseconds traveling back. The distance then between the whale and the boat can be found as long as we use 210 milliseconds as the time of wave travel. I would use the speed formula in this case. Speed equals distance divided by time. We'll use the speed in salt water being quite a bit faster than speed in air. We'll leave the distance as unknown and put in the time of 210 milliseconds. Now a conversion should be done here because our speed of sound has seconds in its units, but the time is in milliseconds. So we should really convert to seconds. I'll introduce a conversion factor where I put milliseconds on top and seconds on bottom. The metric prefix milli stands for 0.001 of something, or in other words, 1/1000th of a thing. So what we could say is that 1 millisecond corresponds to 0.001 seconds. This will have the effect of moving the decimal from the end of the 210. It'll end up moving back 3 places. So we'll have this. Multiply the 0.210 to the other side. And now we can just multiply to get our distance. It's 322 meters. That's how far away the ship must be from the whale.